Hi everyone. So today we are going to see this one sorting mechanism called selection sort. So what we are given is we are given as an array of integers. So all we have to do is we need to put them in ascending order. So it will be not in ascending order. So we have to put them in ascending order. So we are going to use this technique called selection sort to do this thing. So how we do the selection? So how does this selection sort works is, so first thing we'll assume this will start from here. So we will assume the first integer, the first element in the array is the smallest number. So from this point, we have to find the smallest number. So we need to find the smallest number which is lesser than 8. So the smallest number from here which is less than 8 is, so first we check 5. So initially first we'll assume minimum as 8. So first we'll check 5. 5 is less than 8, yes. So next we'll check for 2. So 2 is again less than 8, yes. So next we'll check for 9. 9 is not less than 8. So next we'll check for 5. So so now when we check for 2, so 2 was the minimum, so we added 2 over here. So after this, now we need to check for 9. So 9 is not less than 2, which is the new minimum now. And then which is 5. 5 is not less than 2, no. So 6 is not less than 2, no. So 3 is not less than 2. So the minimum we found 2. So now what we do is, so this is the minimum number. So we just exchange them. So 2 and 8. So we exchange those two numbers. So after that, we come over here. So we are over here. So we come to the next one. So next we'll reset this one. So we'll reset this. So from here, we assume minimum also as 5. So from here, we will check for the smallest number from this point onwards, which has to be lesser than 5. So 8 is not less than this minimum. No, 9 is not less than this minimum. No, 5 is not less than this minimum. No, 6 is not less than this minimum. No, so 3 is less than 5. Yes. So the new minimum will be 3. So now this index is the smallest number from this point, which is less than this one. So we exchange these both. So 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 3, this one is 5, right? So now we go here. Okay, so now we go to the next one. So here we again do the same thing. So from this point on, so minimum we'll take it as 8. So from this point onwards, we need to check for the smallest number, which is also less than 8. So we start from 9. 9 is not less than 8. We start with 5. Yes, 5 is a number which is less than 8. So next, 6 is not less than 5. 5 is not less than 5. So we got this number, so we exchange it. So, so we'll keep it 5. Here we'll keep it 8. Next, so I hope you got the idea now. So next we'll come here. We'll check. We'll so it will be 9. So now we need to check for the number which is less than this minimum. So is 8 less than 9? Yes. So now 6 is less than 8. Yes. Now this 5. 5 is also less than 6, so minimum will be 5. So we are so since minimum is 5, we exchange these indexes. So right, so now we come here. So if we know what we do, we need to check for a number. So minimum is 8. So 6 is less than this minimum. Yes. So 9 is less than 6. No. So we extend these both, 8 and 6. 6. So now we come over here. So we need to check for a number less than, so we have 8. So is this number less than 8? No. So we don't need to exchange. So next we just come to the last step. So after there's no number, we are on the last step, we come out of the array. So that's it. So for each point we need to check the smallest number. So each point we will assume this point is the smallest min, and then from then onwards we'll check for a number which is lesser than that minimum number from that point onwards. If it is minimum is found, we exchange them. We go on like this, we go on till the end, and each time this minimum value we reset. So let's see how to write the code, we can understand easily. So like I had told, we start in the very beginning. So let's write the code for that one. Okay, set. Okay, so we have the this one here. So what we should I write in there? Okay, 8 6. I just write down the number here, 8529 8529563. So first we start from here. We need to check for the smallest number. We assume this one as the minimum number, as the minimum, as the smallest number. So for int I is equal to 0, I less than array dot array dot. So we need to put array dot length minus 1, because each time, right, we are checking from I plus. So if I is 0, we check from I plus from here. So if I is here, we check from I here. So when I is here, we need to check, I should only go till here, and when I is here, J will check for this one. So I should only go till the second last element. So we put I is less than array dot length minus 1. So that's why we put this length minus 1. So next, for int j is equal to I plus 1. So why I plus 1? Because each time we need to check from the very next index of I. So I plus 1, j less than array dot array dot length and j plus plus. So why no length minus 1 here? Why only array dot length? Because each time if I is here, j has to go till the very last element. E- So that's why we need to put array is less. So we need to put j is less than array dot length. So even if array is here, even if I is over here, j has to go till the very last element. So j is less than array dot length. So that's why we put only array dot length minus 1. I mean, so that's why we put only array dot length for j. So once we are here, so like I said, here we assume we have to assume minimum is whatever I is pointing to. So we will, as soon as we define I, we'll put int minimum index is equal to I. So next, what we do here is, so we are pointing to this one. So now we should check for any number which is less than the smallest number. So what we now need to do is we need to check for the smallest number after this index, which is also less than 8. So we need to check for the smallest number which is less than this 8. So what we do here is we if so if this one, so whatever we are iterating out here, if array of j is lesser than array of minimum index, so if it is less, we first thing what we have to do is we need to rewrite this one. So for example, we come 5, right? So 5 is less than 8, yes. So next we come to 2. So 2 is less than this minimum. So next will become 2. So we need to do this one. So if RFJ is less than RF minimum index, so this new minimum, so this minimum index should get updated. Minimum index is equal to j. So so doing this, we will get the minimum index. So we need to iterate through the very end to get this minimum index. So once we come out of this for loop, we will have the minimum index, which for example in our case it will be 2. So now after coming out of this inner for loop, we swap them. So in our example, we'll have 2 as the smallest number, so we need to swap them, 8 and 2. Swap. So write one swap function, swap. So we need to send in the minimum index and we need to send this array I, since we need to, so I is pointing here, right? So we need to send this I, so we need to send this minimum index, which is in our case it will be 2. Okay, so next we need to send the array. So after it gets swapped, after swapping, we can return array. So once, so now we just have to write the swap function. So okay, So let's write the swap function. So static void swap int minimum index int index int array. So next we just need to swap the value present here. This one should come here, this one should come here. So first thing I'll store int temp is equal to array array of I. So array of I will, so I is this one, so this one will get the smallest value what we have. So it's equal to array of minimum index, right? So next array, so whatever is there in I must now be given to that minimum index whatever we have. So array, so that one we have stored it in this temp. So array of minimum index is equal to temp. So with that, yeah, so this one is the swapping. So yeah, this should work. So let's see. Array dot length cannot find symbol 93. So guys, yeah, so this is, so that's all. This is the answer. So this is how we do selection sort. So the time complexity for this one will be, so uh, n square time complexity. Why? Because for each time we'll be iterating through the whole thing. So for this one we'll check this whole thing. So this one will check this whole array. For this one we'll check the whole array. So worst case, like, we need to keep going through each of them twice for the longest length. So like each of them will be, for each of this one we'll be going through n times n minus 1, n minus 2, n minus 3, when n is here, when, so for first iteration it will be n minus 1, next n minus 2, n minus 3. So in the end we'll have n square time complexity, where n is the number of elements, and for space complexity it will be O of 1, O of 1, because we are not creating new spaces here, we are just iterating on the same array. So yeah, so it's not that efficient, but yeah, so time complexity is n square with space complexity of 1. So this is the selection sort. So thank you for watching.